let's look at the difference that frequency has on the passage of a radio signal through a capacitor and an inductor. To do that, we've got a little breadboard here with some resistors. We're going to measure the voltage across the resistors, and we've got a small signal generator here, very much homebrew. It should really be in a metal case to shield it from the radio frequency that it produces, but I didn't have a case big enough, and for various reasons it's mounted as you see it. But it shows us the frequency that it sends a signal out. Signal generators are like very, very weak powered transmitters. They just put out a specific signal, a specific frequency. Oh, excuse me. A specific frequency. And here we have a meter, an analog meter, and that's going to show us how much of the signal that the signal generator produces comes out of the capacitor and an inductor at different frequencies. We can change the frequencies, and we'll see what the meter reads when measuring what's coming through the inductor or the capacitor. So that's the setup here. So here we are then, and the capacitor is in play, it's in the circuit board, and we're going to see how much signal it allows to pass through. We'll see the signal coming up on the, or we'll see the amount coming up on the meter at a frequency of 1 megahertz coming out of the signal generator. So I'll just turn the signal generator on, and we see it's about 3 volts. Turn that off. So the capacitor produced 3 volts at a frequency of around about 1 megahertz. Right. Now let's increase the frequency to 2 megahertz and see what the meter reading says at 2 megahertz for the capacitor. Oh, a little bit more. Just a fraction under 4. We'll call it 4. 2 megs, 4 volts. Okay, turn it off. And now we'll put it up to 4 megahertz and see how much the reading on the dial says then. Oh, we've gone off scale. Better turn it off before we damage the meter. So at 4 megahertz, it was 10 volts plus, 10 plus volts. Quite substantial. Okay, now let's change things around a little bit and we'll measure the inductor. Here it is, little inductor. Bless its little cotton socks. Put that in there like that. And we'll bring the frequency back down to 1 megahertz and see what the inductor does at 1 megahertz. Well, 10, just a fraction over 10 at 1 megahertz. Oops, I have to turn that off and reset it. So the inductor at 1 megs was 10 volts. Let's increase the frequency, 2 megahertz. 7 volts roughly. Okay, whoops. Reset. So at 2 megs it was 7 volts. Now let's go up again to 4 megahertz and see what the inductor does. Oh, it doesn't like that. About 3.5, I'd say. About 3.5. Oops, yes. 4 megs, 3.5 volts. So, now let's go and plot those statistics on a graph and see how they turn out. So, what we can see here is that the capacitor let more electricity go through the higher the frequency was, whereas the inductor let less electricity go through the higher the frequency became. Look, it started at 1 megahertz letting 10 volts through, and that dropped down to 7 volts at 2 megahertz and just 3.5 volts at 4 megahertz. So let's take these statistics and plot them on a graph. Here we are then. So just to explain, we have volts down this side, 0 volts at the bottom, 10 volts at the top, and frequency along this scale here, and it starts at 0 megahertz, then 1, 2, 3 and 4 megahertz. So just taking the statistics, the details off the booklet that I made the details notes in, let's start with the capacitor. And we said that at 1 megahertz it let through 3 volts. So that puts it just about there according to my reckoning. We then said at 2 megahertz it let through 4 volts. So if we follow this line up here until it meets there, it let through 4 volts at 2 megahertz. And then at 4 megahertz, right over here, it let through 10 volts. So it went all the way up to the very top there, which I reckon places it about there. And now I'm going to join these dots up, but I'm going to use a colour pen to do it. If I can find a colour pen, that would be very useful. And we'll use blue for the capacitor. So this is the line that goes, and then it really goes up. That's the trace for the capacitor on this graph. Now let's look at the inductor. The inductor at 1 megahertz let the full 10 volts come through. So that puts it there. At 2 megahertz, the inductor only let 7 volts come through. So this is 7 volts there at 2 megahertz, puts it there. And at 4 megahertz, it only let 3.5 volts through. So I reckon that places it around about, yeah, I'd say around about there. So now I'm going to use a red pen to mark the inductor's inductive reactance. And it's almost a straight line, we can see. So this now shows quite clearly then that at low frequencies, inductors in red let a lot of energy go through, let a lot of radio signal get through, and as the frequency increases, an inductor will let less and less signal come through. And for a capacitor, the more the frequency increases, the more the signal is allowed to get through. But look, there's a strange thing that happens here. At this point where the two cross, where the frequency of this particular capacitor and this particular inductor cross, one will actually cancel the other out. The capacitive reactance will be cancelled out by the inductive reactance, and this point is known as resonance. Resonance. And that is very interesting for us.